Okay, so I want to go through these 3 different examples of what I'm going to call type 1 of integration by parts. So this is the type where you want to let u equal the x term and you want to let dv equal the other terms. Remember, integration by parts is most often used with 2 functions multiplied times each other. So here I have number 1, x times sine of 2x dx. So again, I'm going to let u equal the x term and dv equal the sine of 2x dx. With the dv, the dx has to be included. So I take the derivative of my u, so du is dx. I take my antiderivative of dv, so that's v. And here, let me just write it over here, I'm taking the antiderivative of sine of 2x dx. So this is where that La Jolla theorem comes into play, where you don't have to go do the u substitution. You know the pattern, so it's negative 1/2 cosine of 2x, and that's what this is. Remember, we're just going to put the plus c at the very end, so I don't have to worry about putting it here. Okay, so now I'm going to put it together. So this is u and dv minus the integral of v and then du, which is just dx. So after you get to this point, I want you to take a moment and clean it up. So pull this negative 1/2 outside with the negative, so it turns into positive 1/2 on the outside. Then you just got cosine of 2x on the inside. You ask yourself, can I do this integral? Can I take the integral of cosine of 2x, the antiderivative? I can. La Jolla theorem, so I get yet another 1/2. The antiderivative of the cosine is the sine of 2x, and I carry this along and add the plus c. So we're done. Let me see if I can make it bigger. Here we go. All right, so let me get rid of this. Okay, so here we go. So here's another one. Here's the x term, and here's the other. So let's let u equal x squared, and dv equal e to the 4x dx. So the derivative is 2x dx. The antiderivative, so again, this is why I hit this hard in Math 150. I want you to know and recognize this is easy La Jolla theorem, 1/4 e to the 4x, right? That's the easy u substitution. So that's the antiderivative. So I put it together, uv minus the integral of v du. Okay, again, take the time to clean it up. So take the 2 and the 1/4 and pull them outside to be a 1/2. I'm going to move the x in the front, and then I'm put it beside the e to the 4x. And I'm going to stop and think, is this something I can take the antiderivative of? It is not. I cannot take the antiderivative of 2 functions multiplied times each other, but I can do integration by parts, because that's what integration by parts does, is it helps me find the integral of 2 things multiplied together. So I'm going to let u equal the x, the dv equal e to the 4x. Notice I'm leaving the negative 1/2 out front. So I take the derivative of u and get du, derivative of x and get dx. Taking the antiderivative of e to the 4x, I get 1/4 e to the 4x. So then I have this first part here. Make sure this carries along, right, out in the front, minus the 1/2. Now I've got these big parentheses, so now I'm going to have uv minus the integral of v right here, and du, which is dx. I stop and think, is this something I can take the antiderivative of? It is. 1/4 just carries along for the ride, but I know the antiderivative of e to the 4x is going to be 1/4 e to the 4x, right? So I carry this first part along, minus the 1/2. Make sure you keep the parentheses, and then keep this first part, and then bring this negative 1/4 along, and then take the antiderivative of e to the 4x and get another 1/4, so it gives me 1/16 plus c. So this c just hangs out way at the end. It does not need to be multiplied times any constant. This is a fine answer. You don't need to go multiply this all through. Just make sure that you've got the parentheses in the right place. All right, here's another one. see if I can bring it up a little, make it a little bigger. Here we go. Okay, so here I have x squared and then cosine of 3x. So let's let u equal the x guy and dv equal the other. Again, dv has to include the dx. So the derivative of u is du, the derivative of x squared is 2x dx. The antiderivative of dv is v. The antiderivative of cosine of 3x is, again, La Jolla theorem, so 1/3 sine of 3x. So again, La Jolla theorem is just that easy u substitution, right? So then I put it together. So this is uv minus the integral of v du. Take the time to clean it up. So I'm going to pull the 2 and the 3 outside to 2/3. And I'm just going to write the x in the front and then sine of 3x. So this is not something I can take the antiderivative of by itself, but I notice it's the product of two functions. So this is a great time to use integration by parts. So I'm going to let u equal the x, the dv equal the sine of 3x dx. So du is dx, and taking the antiderivative of dv is v. The antiderivative of sine of 3x is negative 1/3 cosine of 3x. So again, make sure you carry that first part along, minus the 2/3, right? Minus this 2/3 is out in front, parentheses, because now I'm doing parts on this integral. So I have uv minus the integral of v du. So big parentheses out here. So then I'm looking at this integral because this is the last of the parts to do, and I can take the antiderivative of cosine of 3x with La Jolla theorem, right? So I carry these first parts along, the negative 2/3, the parentheses, this part, minus, and then I could have pulled that minus 1/3 out and made it positive. I'm just carrying everything along. Taking the antiderivative of cosine of 3x gives me a 1/3 sine of 3x, so I just kept a negative and sine of 3x. Lots of parentheses, big plus c at the end. Okay, so let's take a big bird's eye view of these three. So here I had x times a sine. Here I had x squared times a cosine. So this one, because it was squared, I ended up having to do parts twice, right? So if it's x or x squared times a sine or a cosine, the power of the x tells me how many times I'm going to have to do the integration by parts, if it's times a sine, a cosine, or an e. So this is a very specific type. So I want you to get to know this type before we move on to the other kinds, which are going to have different expectations.